Welcome to the Pacific Northwest Geodesign Forum. I'm Tim Nyergis, Professor of Geography and Director of the Masters of GIS for Sustainability Management. I'd like to take this opportunity this morning for thanking you all for signing up, registering, being here this morning at this early hour. Hopefully a number of other people will arrive in due time, as it would be. And I'd like to take this opportunity to acknowledge the sponsors of the activity. This event wouldn't occur, at least the students, for there is a free lunch in the world every now and again for students. Students didn't have to pay a registration fee. So the 4 colleges from the University of Washington came together, or at least units, I should say, from 4 colleges came together. The College of Arts and Sciences, with the Department of Geography and the Division of Social Sciences, the Master of GIS Program for Sustainability Management within the Department of Geography. From the College of Built Environments, we have Landscape Architecture and Urban Design and Planning that are part of the Planning Committee. From the College of Engineering, we have Civil and Environmental Engineering. And as engineers, sometimes, as it would be, I'm a geographer, a would-be engineer, as the case would be, I think, all these years. The engineers sometimes have a little bit deeper pockets. They didn't even want to bother to go to their dean for money because they had enough to contribute themselves. So that was quite nice for the faculty to get together and do that. From the College of the Environment, we have the School of Environmental and Forest Sciences. And last but not least, the National Science Foundation funded project. It's called the Cyber GIS Project. It goes by the formal title of Software Integration for Sustained Geospatial Innovation.
Alrighty, the next presentation will be Online Collaborative Geodesign for Watershed Improvement. And I'll go ahead and introduce the speakers real quick. The first speaker is Rob Pahle, and Rob is an assistant research professor at the GDAW Center for Geospatial Analysis and Computation at Arizona State University. His key research areas are decision support systems, integration and workflow processes, visualization, database management, high-performance computing, and user interaction. Previously, Dr. Pahle served as the Chief Technology Officer for the ASU Decision Theater. The second presenter is Mary Roderick. Mary is a PhD candidate in the interdisciplinary PhD program in urban design and planning here at the University of Washington, and a water systems instructor for the Masters of Infrastructure Planning and Management. She's also a member of the multi-institutional NSF-funded Cyber GIS team. Her research is focused on multifunctional and multi-scalar green infrastructure and planning, facilitated by a participatory, cyber-enabled, geodesign-based decision support system. And the last presenter is Dr. Tim Nyergis, and he is the professor of geography here at the University of Washington, where he teaches about the development and use of participatory cyber-enabled geographic information systems for sustainability management. His research focuses on sustainability information science with particular application to watershed resilience. He is the director of the Masters of Geographic Information Systems Sustainability Management at the University of Washington. He is the past president and treasurer of the University Consortium for Geographic Information Science.
And we are going to quickly, my colleague informed me, change out the computer because he has the demo open. We're going to be demoing some live material, so let's switch that really quickly. Yeah, thanks, Brian. Yeah. And here's, okay, thank you, appreciate it. Do you need, how are you tethering to your phone? Yeah. Okay. So
this is not coming up.
Rob and I worked together in the Cyber GIS project, and within that project, we found another vein of collaboration. So that's, oh, yeah, sorry, thank you.
Oh, there you go.
Within the Cyber GIS project, where we both work, we found another vein of collaboration, and that's what we're going to be talking about today. And hopefully we'll be up in just a second. I said he's the meat, I'm the bread. So I'm going to start out. I'm going to frame briefly what we're talking about. He's going to do a demo, and then I'm going to wrap it up. So Rob, Mary. Tim is our supporter and our convener, I'd say. All right, the backdrop for our talk for the watershed that we are talking about is Monterrey, Mexico. With its forested uplands and urbanized lowlands, it's very similar to Seattle. But we're really not going to focus as much on the watershed, which you see partially here framed in blue with the major rivers in red. We're going to focus more on methods and tools that we're using to support this type of planning. So I think it's a nice complement to the Ross and Wass presentation that we've just seen. The Water Innovation Consortium was is a international collaboration, but the main outcome that we're going to talk about is this prototypical decision support system. And I think I'm excited because I feel like we've addressed a lot of the comments in Mike Flaxman's conclusion, the organo design from John Owen, and even the ecosystem service valuation with the integration of VEST and INVEST. So I'm happy about that. But this prototype that Rob will demonstrate brings together data modeling, data synthesis, visualization, and multi-stakeholder engagement. I feel like I need to frame, though, this kind of web-based approach or web and mobile approach. We want to be able to support multiple modes of participation. You have people who are remote. They need to be able to access information anytime. We have, of course, the mix of face-to-face and remote. And then we have just face-to-face. But even there, individuals need access to information and tools. And certainly paper maps are useful, but if you can and work in a digital environment and the CSF enables each individual to interact with analytic models, for example, provide their own input, their own changes, and update immediately. So you can get immediate feedback on kind of what your perspective would be. And again, he will show this. The other, from a systems perspective, is the degrees of integration. And I feel like Mike touched on this some in his talk. You have everything from integration at the glass, where you essentially have information coming together, but in the background they're not communicating. They're not programmed to interact with each other. It's basically just bringing disparate pieces together in a place on your computer screen. You have loose coupling in systems where you have standardized interfaces, and then you have tight coupling where you have either highly specialized systems that need strong or really good throughput and control, or you have legacy systems. I come out of a development world where we have lots of old COBOL programs. And the CSF can bring all of these together, and that is the beauty of it, the complex systems framework that Rob will be demonstrating. I also want to place the CSF within the context of the Geodesign framework from Carl Steinitz. I expected that framework to be presented in detail, which is why I've kind of abstracted it here. But there are the 6 different types of modeling and 3 iterations that increase in sophistication as you move through them. Tim likes to refer to the scope, design, and implement phases, which I think is really useful. And this is presented in a linear way in Carl's book, but of course he admits that that animation does not work on this computer after all. Oh, yeah. It's a far messier process, and sometimes you already have well-developed analytic models that you need to use, or you already have made some decisions and you want some justification for those decisions, but you know you have certain priorities. So I think that it's important to be able to kind of support that entire process, and the CSF and this Water Innovation Consortium project is a good example because they started out with water quality issues and drought being their concern. Hurricane Alex hit mid-process. Severe flooding hit mid-process, and suddenly everything needed to be reframed. You needed to have a new issue framing and new solutions, and through the CSF they were able to add this and move forward rather than having to start from scratch and rewrite these amazing documents that we've seen to kind of reframe the issue. You could do this dynamically and online. So I'm going to switch over to Rob now, and he's going to demonstrate.
I'm going to show you a little bit how this looks like, and let me just drag this over on the other screen. So, and this runs all live, so obviously there's a high likelihood that something does not work. These things are. Okay, so what I'm showing you here is basically a setup that is completely web-based. We generate the interface completely automatically. Right now, I'm just having no active components on the screen. You see at the bottom 7 kind of picture postcards, if you will, of the actual screens. And this context here is a little bit, closer. It's basically a little bit to frame this also. We heard just in the previous talk how important it is to address the institutional aspects, right? So we actually, and let me just click on one here to make this large. We actually, in this whole process, we actually analyzed the whole institutional setting and who is actually involved in every part and had their input in this and tried to work with them so that in the end you can actually get to real decisions and real results rather than make a nice decision environment and everybody's like, oh yeah, that's shiny. And you can't actually not implement it and use it. And in that process also, a lot of the actually critical threats and risks were analyzed. And this was all the stakeholders that kind of contributed to that in the region that we all pulled together. So I just wanted to point out, because it becomes a little bit more important, the deforestation part. That was one of their main issues that they were thinking is important. And interestingly, that actually was dragged through this whole project, although we suddenly were focused on flooding due to the hurricane event. Okay. So what I'm doing right now is, so these are all little web pages basically, and Mary told us that you can actually have a multi-user interaction, and I can actually with a cell phone see the kind of same things that I see on the big screen. So I can have several people work on this at the same time, and I'm using the cell phone here just to switch context. So you could open the same page somewhere else in a different place and work on the same issues. So since we suddenly talked a lot about the flooding problem, you have to kind of find the adequate models that basically describe this. What we used is a model that runs on a supercomputer that basically looks at a watershed and the water flow, looks how the flooding is. I'm not an expert in this, but we had Enrique Vivoni that kind of modeled all these kind of things. Now, the problem with them is, we heard earlier that the question is, how do you tightly couple this? If you're in a decision environment, you don't want to wait for a week to get your result. If we all come together, we click a button and we want to see a result, that's not going to work. So if you have these kinds of complex models, you need to think about strategies that are efficient in accelerating this and still making these useful tools. So what we did is we ran a whole bunch of scenarios that basically described the problem space for us. So you can see here, these are the peak flows. The river, the Santa Catalina River, is the main river, runs through the city. Is usually completely without water, right? And then there is the storm event where you have a huge surge, and then slowly it kind of tapers off. And the surge kind of differs basically based on how much you reforest. These are the scenarios that we then picked out of the stakeholder engagement. So it's all tightly coupled. You can also see that from the green scenario, which is kind of current conditions, we don't reforest anything, to the red scenario, which we reforest almost everything, is about 15%. So it's actually not enough. Still, the stakeholders felt that reforestation is the way to go because it has so many side benefits, right? So suddenly the picture becomes larger and larger and larger. You cannot just look at a single sliver of the problem, but you need to kind of holistically look at the picture. So now, in the next step, I just wanted to show real quick kind of a prototype environment that came out of this, where we have all the bits and pieces, and this is now a live running environment that runs on a cluster. So normally, I put these postcards here. Normally, we have 7 screens. You can actually use as many screens as you want, but for these environments, we use 7 screens. So you can see that we have basically from left to right. It's still loading. Okay. We have the concept of preview of before and after. So oftentimes, if you want to make policy decisions, right, you have a status quo. And the status quo you act on with a policy intervention. And then afterwards, you basically see what the result is. So in this particular case, first thing we want to do, we want to see what is the event that we're looking at, which is the Hurricane Alex. So I've just put that onto the system, and you can see we have the flooding, and this is modeled with the supercomputing model. We bring some statistics, and we work with the IDB, and IDB uses these kinds of qualitative measures to look at the changes and the effects for the people. And then here on the right-hand side, you see the city. I got a lot of trouble for the blue. The blue is not the flood. Blue is the city boundaries. Red are the rivers. Luckily, the flooding went through the city in the riverbeds, more or less, but it basically pulled down bridges and roads on the side. It basically was quite a bit of devastation. So, and now I have, in the second step, I can put my intervention on. And the intervention here could be reforestation. So I'm just going to do that. And then at the basically future water event, what would happen if there was a Hurricane Alex with the reforestation is the question, right? And you can see there's actually kind of a drop in the peak water flow. And you can look at all the effects go back and forth. Now, you can actually run this on the fly with different types of reforestation. So if you choose to draw different reforestation, it'll actually recalculate all these things, right? So, and then you can create these scenarios in an interactive session, save this, and in the end, basically have a discussion about these scenarios. Bring them up, compare, contrast them, see which ones you want to implement and where you want to go, right?
This is the SPT part of it, the structure participation toolkit that has been developed here at the UW.
Okay, so I need to click over here where you see all the feedback, right? So if I look here, I can basically see what people would comment on the different scenarios and how they would affect the overall system. So, and just to give you a little bit of background, here you can actually see what we're seeing on the screen. So that all the screens are completely generated. You have three kind of types of inputs. Blue are the inputs that you see where you drop down or you draw things. Then you have models, which are the green components, and then you have outputs, charts. And you can actually wrap any type of model that you want into the system, as long as it doesn't have a user interface in a way. And I can open this up, and I can actually write on the fly what I wanted to do. Of course, this takes a while. There you go. So you actually see the code that sits behind this, and you could manipulate this. And obviously, a decision maker doesn't want to do that. So we're looking at three types of user groups. One would be the decision maker that sees the nice shiny screens, which you can, it's like PowerPoint. You can move the charts around and organize them however you want. The next step would be an analyst that basically knows how these models work and how they could plug together. And the third step is a developer that actually works on the model itself. Okay, let me switch back to the PowerPoint. If I find the mouse. Let's just close this. Okay, here we go. We did this also in kind of other environments. So here you see a solar sighting environment. We pull together a lot of geodesign aspects. Where is it located? Distance to roads, et cetera, et cetera. But then we also pull together technical aspects. So here you see the power flow map. And economic aspects. So you can basically use all kinds of different models. Okay, we're running out of time, it seems.
So he had another couple of those. Click through this because, of course, all this is based on decision science from ASU and the decision theater, as well as the structure participation methods that we use in the SPT. So there's a whole bunch of literature and a basis for all of this that we won't talk about. And we have other things that we want to be able to do, like support public participation. There's lots of great ways to do that and integrate that into an online environment. On the system side, using ontologies to organize models so they can be loaded dynamically. That gets more complex, and I probably need to stop now. But I hope you have a sense of a way to use software like this to generate any kind of web environment to do any type of collaboration. That's what we're aiming for. Thank you.